Hello and welcome to our first video on using SPSS. This is going to be the software package that we will use that is a dedicated statistics software application, I guess. We have done in our B portion of topic 1. We've done a frequency table and a histogram by hand. We have also seen, for those that are interested, how a spreadsheet, specifically we're using Microsoft Excel, can be used as a more efficient, sophisticated calculator, bringing some quality of life um, items to the table and speeding things up in the process, but not doing anything for me. I still have to know how to do it. On the other side of the spectrum is statistics software that does everything for us. Now I have SPSS open here. It doesn't really matter which version you use as far as I can tell. The main reference for what we're going to do is the Statistics and Data Analysis for Nursing book by Pollitt. And in that book, they have collected uh, information. They interviewed 1,000 different women in low-income communities and collected a whole bunch of information, provided those files or put that information into SPSS and provided that information. So we're not going to put things into SPSS, we're going to use those data files. So I have that book here. Oopsie, just open it. Open it. There we go. Data sets, and in the textbook there's the URL for where to go to find these. There are different ones. We're going to focus on the first one. And because this is our first um, introduction, our first video on SPSS, sorry, I just lost my window. It's on my other monitor. Come on, drag over. It doesn't want to drag. Okay, get over. Very unhappy right now. Not drag. I see you. You want to be dragged. There we go. Now, since I lost, man, this window does not want to play with me today. I just want to make it as big as possible. We're recording video window. Come on. It's gonna see realize how unprepared I am. Now in SPSS. So what we have here is all the information that's been put in for us. Now, you can of course put your own in, but for the sake of being more realistic and seeing something bigger where the statistics application really comes in, we'll use this file for all our upcoming videos on this subtopic. So you see here, it looks very spreadsheet-like, though it's not the same. We have 1,000 different people that were interviewed and various pieces of information were collected. They have an ID number, not as relevant for us. We can just look at the row counter as well. So we can navigate vertically just like we can for a spreadsheet. And in our data view, we have two tabs here, data view and variable view. Data view shows all the variables as columns and the individuals as rows. So I can make it bigger and smaller and so on. Hopefully this is big enough. So I could look, for example, at the 10th person in this list, answering their question, age, 1, birth. That's what their age was when they gave birth for the first time, and the 10th person answered here 15.53. Now they probably answered in months, and we made it a decimal so that we have an appropriate variable. So we have different variables here. This was for this person, how old she was when she gave birth for the first time. That's just an example. We also have at the bottom tab here the variable view. This gives us more information about the individual variables here under name, and I can make the label here bigger to find a description. So for example, row 3 here is that variable we referenced, age at first birth. It has a little description here in words as well. And we can see here it's a scale variable, just a numeric variable, the most common one we have. But we also see nominal, categorical variables, ordinal variables, and so on, depending on the information that was gathered. For example, the next one here is race or ethnicity. And you can see that's obviously going to be a categorical nominal variable. We can click here in the values column of that variable, and the little square afterwards, we can click on that and it opens and shows us the different labels, so that the coding that's used for the different groups. So when we see someone having answered their 3, that would correspond to white, not Hispanic, and so on. So we can get more information in the variable view tab. So let's see how we can, let's go back to data view. Let's see how we can actually see a frequency table, for example, and eventually a histogram. So what we're going to do is we're going to click on Analyze at the top. Double check if everyone can still see that. Yes, big enough. Look at my blue mouse here, mouse cursor. Analyze at the top. Second from there is Descriptive Statistics. That has another drop down, and I'm going to click on Frequencies because that is what we want. Now I can pick which variable I want. Let's go with that race ethnicity variable. I select that, click on this middle arrow, and that makes it my variable that I'm interested in. And then I can click on OK. And then a different window is going to open up, the output window, which is a separate window, where all the output is going to occur. Let's see if I can zoom on. Can't zoom. There's probably a way to zoom. I never zoom because it's big enough on my screen, right? Let's see. Squint. Hopefully this is big enough on yours as well. And you see here at the bottom, I have my frequencies. 2 scores were missing, 998 were there, of the 1,000 I know, of course. And we have different percentages. 80.3% were black, not Hispanic. Hispanic 12.8%, and so on. So it looks very similar. It's just done for me. Regardless of the type of variable, it does this cumulative percentage column where it takes the first percentage and then the next one gets added to that and the next one gets added to that. But in the case of a categorical variable, that doesn't make much sense, right? Because there's no ordering to these. I could have had Hispanic first, and then this column would be very different. But in the case of a numerical variable, that might make some sense, and we'll get to that shortly. So I have my frequency table very easily done for me. And I can just read off information from that. Let's rerun this just to help us remember the steps. Analyze tab at the top, Descriptive Statistics, Frequency. My race ethnicity variable is remembered to be in there. I can also, let's cancel that. I could also use here size. No, that's fine. Sorry, I'm thinking of something else. Frequencies. Let's go back there. Let's click on charts before saying OK, charts, because I want to tell it to include a bar chart. I know this is a categorical variable. Bar chart is going to visualize that frequency table information. Frequencies or percentages, let's go percentages, and we'll say continue, and then we can say OK, and it's going to output for us. It's processing a nice bar graph that just visualizes the information we already knew. Then we can answer again from the table, from the graph, answer percentage questions. How many were Hispanic? 12.8. How many were falling under the other group? 1.4%, and so on. Okay. So pretty standard stuff. Let's go to a numerical variable because that might look a little different, might be able to answer different questions. But still, we're going to go to Analyze, Descriptive Statistics, Frequencies. Now you'll see our variable that we used previously still in there. You might want to select that, click on the arrow to throw it back. Let's pick a numerical variable. Let's pick maybe high grade, the highest school grade completed, which is actually the number of years spent in school. But we can go to the variable view and see more of a description there. But that is what this variable, what information it collects. We can just that, and you'll see here, let's just look at the table first. Now this is of course in order from 1 year to the highest, that was 16 years of school. And you'll see different percentages here. The majority spending 11 to 12 years in school. Now the cumulative percentage might make sense because I can ask what percentage of people spent at most 10 years in school. Then at most will be 1, 3, 5, 6, 7, 8, 9, and 10. And the cumulative percentage will add up all those percentages and already give me that in my table as 24.6. So I can more easily group some of these scores together if I want to know certain things, not just individual specific years, but maybe a range. The cumulative percentage can help me. And then we also have our histogram. In this case, we asked for a bar graph, remember? It still remembers what we did. So it's going to give me a bar graph. Let's scroll to the bottom so we can see where it's going to put new things in for me. Let's go and ask to do it again. Analyze, descriptive statistics, frequencies. In this case, just want to see if I'm not missing anything. Let's first, we could do it this way, it doesn't matter. Let's go to charts again. This time ask for a histogram. We can actually ask it, show normal curve on the histogram to compare it in terms of skewness and kurtosis. Say OK there, and let's say OK. It's going to do that. Still leaves little gaps, maybe just for visual clarity. Same table, you see that 24.6%, the percentage of women that completed at most 10 or less number of years. So here we can see our histogram. Now you can choose to not be distracted by this normal curve, just an option. Of course, if it was a checkbox, we can check or not. We see our histogram here. Seems fairly balanced. The peaks sort of both of these do correspond to the center position where it would normally sit in a perfectly symmetrical distribution. So visually, histogram's nice. I can't necessarily uh, see any obvious skewness or kurtosis, perhaps. I definitely can't see. It looks like the kurtosis is positive. It goes a little higher. It's a little narrower and steeper than this comparative normal distribution curve. But as far as skewness goes, I won't be able to say much with confidence. It could be just so slight, right? We can actually go and ask a little more. We're going to redo our frequency table in histogram, analyze descriptive statistics, frequencies. We have clicked on charts and asked it for a histogram, show the normal curve. Maybe I don't want to show the normal curve this time. We can also click on statistics. And there are other things that we can do here that we'll get to in later videos. Right now, we want to ask it, can you calculate for me the skewness index, kurtosis index, because I can't visually see much. It could be just so slight. So I want a number to help me outside of my subjective perception of what the graph looks like, right? Number can a way to measure these uh, skewness and kurtosis properties. So let's see where that is. That's actually done first here. So we see the skewness is measured for this distribution at negative 0.727. Now, I'm not going to explain what the standard error is right now. The general rule of thumb is uh, if this is twice the size of the standard error, then there is, I'll say, quote unquote, significant skew outside of the normal distribution. Kurtosis, quite positive and big, much more than its standard error, or twice the standard error. And we thought we saw something that peaks a little higher and could be a little narrower than the sort of baseline normal curve. This now puts a number on it. Oh, here it is, right? If I want to see the curve again. This now puts a number on it. Yes, there is a positive kurtosis. Quite a bit more than I maybe thought. The skewness, yes, there is a negative skew. I have seen that negative skew? Now that I know the number, I could say, ooh, well, maybe there's a negative. The tail on the left is a little bigger. In truth, I would not have seen that. And we see also it's not very big, negative 0.7. So there is a little bit of a negative skew, but it's not big. Having these numbers that we call measures, or in this case, a skewness index, to help me see a property that might be so slight I can't visually see it. Or if I can visually see something, I don't know exactly. Is it a lot? Does it just look a lot? It's hard to trust that visual interpretation of a graph, right? I need something specific that in this case, skewness and kurtosis, the calculation is a little bit too fancy for us at this stage in our introduction, but the benefit of the statistics software comes in then that even at an early stage, I can learn how to interpret numbers I can't necessarily calculate very easily by hand. All right, so this gives us hopefully a fairly, I wouldn't say good, but decent introduction to SPSS. We'll revisit this with the same data set and look at how we can sort of use top concepts that we learn in the different topics. We'll come back to revisit SPSS and see how is that done in a software package that is actually used uh, and is very popular among the social sciences. So next up, we will look at, move on to topic number 2. I'll say at this stage, we're not going to do part C every time, especially in these early topics. Sometimes I'll merge them. So we'll look at little snippets of how things are presented and referenced in existing research papers and articles at the end of topic 2. So right now we're moving on to topic 2, practice SPSS, play with it. It's definitely a handy option to have, especially as the statistical calculations may become more and more involved. Right, until next time.